Welcome to the third part of the AIA New York State's live webinar series, Reimagining Digital Transformation for the Architectural Profession. My name is Nate Rozzi, and I'll be your moderator for today's program. The session will run for approximately 1 hour with time for questions and answers at the end. In order to receive the One Learning Unit, you must be present for the entirety of the session. There will be 3 points in the program when words will be displayed on the screen. They will also be repeated in the chat box. Take note of these words as you see them. You'll be required to write them on your CE card link that we provided in the chat at the conclusion of the program. This card must be filled out and returned to us no later than tonight at midnight. Again, please be sure to open your chat box to see these words and to see the CE card link. Questions and participation throughout the session are encouraged. If you have a content question for the presenters, use the chat box at the bottom of your screen. If you're having any technical issues or have a question about the webinar itself, use the chat and we'll do our best to answer during the webinar. As a reminder, please keep your microphones muted and your cameras off for the entirety of the program. Today's webinar is made possible with the support of our allied partners you see here. We appreciate their contribution to the architecture industry. Their support does not constitute approval of any method, product, service, enterprise, sponsorship, or endorsement by the AIA New York State. This presentation is protected by U.S. international copyright laws. Reproduction, distribution, display, or use of the presentation without written permission is prohibited. This program is registered with AIA CES for continuing professional education. As such, it does not include content that may be deemed or construed to constitute approval of any method, product, service, enterprise, sponsorship, or endorsement by AIA New York State. The statements expressed by speakers, panelists, and other participants reflect their own views and not necessarily reflect the views or positions of the AIA or AIA New York, local components, or those of the reflective officers, directors, members, employees, or any other organization associated with them and involved in the planning and production of this program. Questions related to specific products or services may only be addressed at the conclusion of this presentation. This webinar and associated materials are being provided for general education purposes only. Information provided during the webinar and in the materials should not be construed as professional advice. Participants should consult with a licensed architect or other appropriate professional concerning the subject matter of this webinar. The materials and their application for specific facts or circumstances. Statement of the webinar moderators, panelists are their own and not statements of AIA New York State. Today's learning objectives are displayed on the slide on the screen. And our first continuing education word today is parametric. Again, please make sure to write this down. It will also be displayed in the chat box and can be entered in your CE card following the presentation. My name's Nate Rozzi. I'm an architect and principal at Rozzi Architects. I'm a past president of the AIA Rochester chapter, the current director on the board of AIA New York State, where I chair the technology discussion group that's presenting this webinar series. At this time, it's my pleasure to introduce our speakers for today's webinar. Carlo Bailey of Topos, and Lorenzo Villaggi of The Living, an architect research studio. Carlo is an architect turned research data scientist currently building products at Topos. His work focuses on machine learning, architecture, and creative coding. He holds architecture degrees from both Kingston University and Columbia University. He's worked at Foster and Partners and Shop Architects. He's taught graduate design courses and lectured widely on the applications of machine learning in the AEC industry. He's been published in numerous scientific journals, and his work has been featured in publications like Wired Magazine, the New York Times, and Architectural Digest. Please welcome Carlo Bailey.
Thank you so much, Nate, for the introduction. Let me share my screen. Can everyone see my screen? Thumbs up, Lorenzo, if that's clear. Great. Yeah, so thanks again for the introduction, and thanks everyone for joining today. Happy to be here. Today I'd like to discuss a few things. And I should say I gave this talk in January of this year at the School of Architecture at CUNY in New York. And obviously the world has changed somewhat since then. So for the most part, this presentation remains unchanged, but there are, given the developments of 2020, there's certain modifications at the end, which I'll go through. And, you know, I'd like to discuss a couple of things. One of them is some major developments taking place in cities and commercial real estate, which I feel reflect wider socioeconomic developments or shifts. And then I'd like to show how these changes are being addressed by some of the technology and research we do at Topos. So, you know, I'd like to start with this quote, which is fairly cliched at this point, but it's that in the future, every company will be a software company. And this was said back in 2011 by Mark Andreessen, and it was at the beginning of the post-recession tech boom, which has been going on ever since. You know, that boom has given us the household names of WeWork, Airbnb, Uber, etc. And at the time, it seemed like technology could take on any challenge, and that there wasn't any industry that was safe from disruption. But today I would argue the reverse is happening, that every software company will have a physical presence. And, you know, some people call this clicks to bricks. And we're seeing this in, you know, companies like Airbnb's foray into urban development via their Sumatra arm. And I used to have a slide next, which was the Sidewalk Labs Toronto project, but that's obviously been scrapped following the developments of 2020. But there's also other companies like Toyota proposing a new city. And I think personally, some of the more interesting companies moving into physical spaces, companies like eFlux. And eFlux is a digital publication platform that have, you know, created one of the most hippest, trendiest bars in Brooklyn. And you also have companies like Glossier, which again is another digital first platform, which have, you know, created their kind of Soho flagship presence in New York. And we also have, you know, technology moving into the residential market. It's not just commercial real estate. We have companies like Fly Homes, which will buy your house for you, Open Door, which will buy your house from you, and Divvy, which will rent your house to you. And of course, there is, you know, Wall Street and big finance making drastic pushes into the industry too. So this all begs the question, why is there this influx of big business, technology, and capital into the built environment? And, you know, you could argue that Glossier's push into Soho or Airbnb into urban development is a, you know, is for a push into R&D or marketing even. But I would argue these pushes into commercial real estate in the built environment reflect wider economic changes in society. And one of those is the asymmetry, historical asymmetry between supply and demand within things like the housing market, right? That we are seeing huge demand for housing in cities across the country and the world, in fact. But at the same time, there's been a dearth in new homes built nationwide. And this is inevitably driving up the prices of existing inventory. And another aspect is, you know, inequality levels are dangerously high. And the gap between the wealthiest members of our society and the poorest is vast. Now, this chart hints at one aspect of that, which is wage growth versus the cost of housing. And wages have, you know, grown approximately 20% since 2012, whereas the average house prices have grown by 60%. So consequently, a lot of first-time buyers are unable to enter the market. And this is not just happening in residential real estate, this is happening in multiple asset classes within real estate, namely commercial real estate. And so these rising inequality levels are making the amount of people that can actually develop properties, that can buy houses, that can afford the exorbitant leases of commercial real estate, you know, pushing them into a select few members of society, big companies and big tech and big capital. Now, the consequences of this are not hard to discern, right? We're seeing the increasing homogenization and loss of character in cities from New York to Istanbul. And writer Carl Shaker, I'm sure some of you are familiar, who wrote many articles on the emergence and ubiquity of the current fetishization of insta-ready, mid-century modern decluttered spaces. We're seeing the same minimalist furniture, reclaimed wood and industrial lighting that have been commercialized by global brands like Airbnb and WeWork spread across the globe and cities throughout. And these developments are most pronounced, right, the homogenization of the built environment are most pronounced at the urban street life level, where once neighborhood defining small businesses, which were the cornerstones of local music, culture, and food, have been replaced by, big brands that's backed by private equity that peddle the same homogeneous aesthetic. And these are just a select few of those. Now, there's been a lot of talk about the retail apocalypse, which, as I said, I gave this talk back in January, and people were talking about the retail apocalypse, and they've been talking about the retail apocalypse for some years. Now, COVID-19 has only exacerbated those concerns. And so we are seeing a general flattening of the culture in cities across the country and the world. We're seeing the hollowing out of small players and the increasing concentration of retail into the hands of chains backed by big private equity groups. And, this is, as I said, COVID-19 is only going to exacerbate those problems. Meanwhile, in architecture, the industry is still operating in a vacuum, still designing the shiniest, sleekest, ever taller buildings for whatever dictator, despot, or developer comes their way. Now, of course, there are some firms pushing the boundaries in terms of materials, construction processes, and project delivery. But for the most part, architects and planners, anyone that's involved, a professional that's involved in the construction of the built environment in cities are still, going on as business as usual and are failing to address some of the major challenges that we're seeing in our cities: the lack of housing, affordability crisis, inequality levels, and inclusion. Now, I'd like to shift gears a bit and think about how we can address some of these challenges with new technology and data. And I always like to go back to this Stuart Brand diagram, which he wrote for the Whole Earth Catalogue some decades ago. And it talks about buildings in relation to permanence and time, right? And so the various lines here depict elements of buildings which are the thicker the line, the less frequently that element changes. And so you have the site, which is the thickest line, which is obviously the most permanent aspect of any built project. Then you have the structure, which is the next step down. And then, all the way to the stuff in the middle, which are things like the furniture and objects that, change fairly frequently. Now, I would like to expand that logic to the scale of the city and think about cities in terms of layers of time and permanence. And then, so, you would start with the neighborhood, which is the site, which is the most permanent aspect of any city. The next layer down would be things like infrastructure and then zoning and the buildings. And architects and planners are well versed in dealing with the, certain, more of the permanent aspects of cities, things like zoning and buildings. But the agency, when it comes to things like programming the sidewalk or programming the space in between, we tend to shy away from. And I think those are the elements that can address some of the challenges that I mentioned previously. Like, we can start to answer questions like, how does street life encourage inclusion? How does it foster interaction within and amongst communities? So, now I want to shift gears again and tell you how we at Topos are taking a more data-driven approach to thinking about and potentially designing and operating the built environment in cities across the country. And much of the work I do at Topos is geared towards location intelligence, we seek to help companies and individuals make better decisions regarding the built environment in real estate. And one of the questions I've been preoccupied with at Topos and generally in my research, which is, how can we better understand the relationship between the vibe of a place, the vibe of neighborhoods, and the retail culture within them? A lot of the time we walk around cities, you can tell a lot about a place by the types of storefronts you see. For example, you wouldn't be surprised seeing a Soul Cycle in a neighborhood like Tribeca, or an artist-owned gallery in a neighborhood like Ridgewood, for those of you that are familiar with New York City. So, using data from thousands of different sources, I wanted to tease out some of these relationships, the relationships between brands and culture, or storefronts and a neighborhood vibe. And so what you're seeing here is, an example of using sweet green, where this is mapping the density of sweet greens in neighborhoods across the country. So density meaning the number of sweet greens per square mile versus the number of people with bachelor degrees in the neighborhood. And you're seeing a very strong positive correlation between the number of sweet greens, or the density of sweet greens in a neighborhood, and the number of bachelor degrees. So this tells us that sweet green likes to locate and consistently locates within neighborhoods that are have a highly educated population. Similarly, Equinox, the kind of luxury health and wellness brand, likes to locate in neighborhoods with very high income. And so the colored lines, the colors represent various metro regions across the country. The thicker the line, the higher the income level. And again, you're seeing a very positive correlation between Equinox and income of neighborhoods. And, something a bit less intuitive is La Colombe Coffee, which again is a kind of boutique coffee brand located in some of the top metro regions across the US. And this looks at the relationship between distances between La Colombe Coffee and art galleries within the neighborhoods they locate. And you're seeing that there is here a positive correlation between the number of art galleries, or distances to art galleries, between La Colombe Coffee and the number of La Colombe Coffees in the neighborhood. So this means that La Colombe Coffee likes to locate in neighborhoods where there is, high-end art culture, high art, stuff like that. So again, this speaks to what I was saying before, where there is a connection between a neighborhood vibe and the storefronts you see within them. Now, the previous slides are looking at the kind of linear relationships between brands and neighborhoods, but we could also scale this and use machine learning to cluster brands based on the similarities or co-location patterns between them. And so this is a snapshot of a clustering exercise we've done, where we look at the location patterns between brands and cluster them based on the similarities between those location patterns. So brands that locate near to each other will be within the same cluster. And so the clusters here are fairly intuitive, right? We see brands like Nike, Puma, Converse, etc., clustered together under a kind of sportswear category, and whereas brands like Dolce & Gabbana and Burberry are under the kind of luxury brands. And this, again, would be fairly intuitive. You could arrive at this yourself, but what we're able to do with machine learning is do this at scale across tens of thousands of brands across the country and even the world, in fact, and to kind of categorize these elements, on the fly and autonomously. And, as I said, I gave this talk back in January of 2020, and I'm almost out of time, so I'll try and rush through the last few slides. But I gave this talk back in 2020, and the rest of the talk tended to be a further deep dive into how we're thinking about retail and vibes between neighborhoods. But as COVID-19 happens, it came along, and I think it's relevant to the discussion of neighborhoods and vibes. And so what we did at Topos is switch gears the last few months and dedicate a lot of time and resources to thinking about how we can use our geospatial data to think about how we can understand the spread of the virus and the disease across communities more granularly. And so we built this COVID-19 compiler, which I encourage all of you to look at, which enables you to explore data on COVID-19 across multiple dimensions. So here you're looking at the number of cases per capita versus household median income. And one of the things we also looked at was how if we can disaggregate COVID-19 data from county level. And what do I mean by disaggregating data? Well, we're used to seeing COVID-19 data at the level of counties. So this is a New York Times map, which I'm sure you're all familiar with, which looks at COVID-19 cases at the county level. Now, county level is a fairly, broad geographic unit. And so you're not able to get that much information about how COVID-19 is affecting specific communities or neighborhoods. So what we did is, on the left, you see COVID-19 data at the county level. So you're seeing a snapshot of, Manhattan, the Bronx, Staten Island, Queens, and Brooklyn. And, according to this map on the left, you'd think that, there's the same number of COVID-19 cases across the whole of Brooklyn. Where on the left, this is our foray into disaggregation, where we are distributing COVID-19 cases using census block group, which is a much finer geographic unit than counties. And we're weighting the redistribution of cases according to variables that correlate highly with COVID-19 cases. So in this scenario, we used population density to redistribute COVID-19 cases according to block groups. And so, quite intuitively, you're seeing that actually Queens, areas of Queens and the Bronx, which were some of the most impacted neighborhoods in New York, kind of come out, which reflect more of, what was happening on the ground. And we're able to do this across the country at scale. So I could continue, but I'll leave time for Lorenzo to take it from here.
You have a few more minutes if you'd like to keep going, Carlo.
Oh, okay. Sure. I will continue. So another thing we looked at is predicting COVID-19 cases with tax data. So, as I said, Topos has a lot of data across many different variables. We have data on retailers and businesses, but we also have data on tax data and demographics. And so I'm sure you're all aware that there has been some links between COVID-19 cases, the number of COVID-19 cases, and the income levels across communities where, so this is looking at the correlations between various tax metrics and the number of COVID-19 cases. So here we try to tease out tax variables, so IRS data that were reflective of the upper and lower portions of society. So things like child tax credits, which are only open to members of society that earn below a certain threshold and are proportional to the number of children and kind of income level that you have. So the higher the child tax credit, the lower the income we can expect, versus looking at metrics that are more familiar to the upper echelons of society, which are things like capital gains, which are in income made from investments, which typically are not available to lower income people. So what you're seeing here is fairly intuitive. You're seeing that the things like child tax credit is highly correlated to number of COVID-19 cases. In fact, it explains 80% of the variation in COVID-19 cases, versus capital gains is negatively correlated. So where we have more child tax credits claims, you're seeing higher COVID-19 cases, and where you're seeing more capital gains claims, you're seeing much lower COVID-19 cases. And so what we did was build a regression model and fed it data just looking at tax data, and tried to predict the number of COVID-19 cases at the zip code level across cities across the US. So we trained the model on COVID-19 cases. And by the way, this is a Medium article, so I encourage you, if you want to dig deeper, you can kind of Google this and kind of learn more. But we trained the model on tax data in New York, and then predicted COVID-19 cases in, so what you're seeing on the left is Chicago, and on the right is Baltimore. And we were able to train a fairly accurate model using just tax data in New York. And so what this tells us is that the relationships and the tax variables in New York are fairly consistent. And so although, Topos is a location intelligence company helping real estate companies with their location decisions, you know, in general, the geospatial data we have is applicable to many different industries. So in this case, we could think about helping epidemiologists to think about how other factors other than just, you know, existing conditions and typical medical data can inform their models and inform their approach to dealing with the spread of the virus. So with that, I will end it there and hand over to Lorenzo. Thank you.
Thank you very much, Carlo. Anyone who has not checked out the Topos COVID-19 tracker, I highly suggest that you do so. It's been one of my go-to tools through the pandemic. So the next CE word that we have is platform. You'll see that repeated in the chat box. And remember, the first CE word was parametric. The second one is platform. Type those in at the link at the end of the program on your CE card. So our next presenter is Lorenzo Villaggi of The Living. Lorenzo is a senior research scientist and lead computational designer with The Living. His projects and research focus on generative design for the AEC industry, data analysis, and computational geometry. Lorenzo has a Master of Architecture from Columbia University, where he has returned to teach a graduate seminar. He has applied his techniques and research in many real-life projects, some of which he will be sharing with us today. He's published several peer-reviewed papers, and his work has been exhibited internationally at renowned venues, including the Centre Pompidou, the Chicago Biennial, the MoMA, and the Milan Triennial. Please welcome Lorenzo.
Thank you very much, Nate, for the kind introduction. Gonna move to sharing my screen. Okay. Can you guys see the full screen?
Yes.
Awesome, fantastic. Yeah, so thank you very much, Nate, for the introduction. It's really, and also thanks to all the organizers and the AIA team for inviting me. I'm really happy to be here and share and talk about some of the work that I've been doing the past few years together with my team. So again, my name is Lorenzo Villaggi, and I'm part of The Living, which is a design and research studio within Autodesk Research. And my talk, called Design Space, deals with an emerging data-driven methodology, also known to many as generative design, that me and my team have been developing for the past few years, but also implementing to solve real-world design problems. And I'm gonna try to explain how methodology can enrich and unlock designers' creativity and expand and enrich the space of design possibility. And I'm going to do all of this through a series of case studies and real world projects through a range of different scales. So a little bit more about The Living. We are a design and research studio, but we're also very much embedded within the practice world in the context of the AEC industry. So while we simultaneously work on new ideas and new technologies within the context of AEC, we also try to test these ideas and the new kind of technology in the real world. And we try to test it with clients, with real constraints, real requirements, and often really push to achieve and get to physical, tangible outputs of our experiments. So this slide is really meant to taste and of the breadth and diversity of work that we do, from commercial buildings, university buildings, temporary installations to push the boundary of new sustainability models, as well as more interactive kind of work that deals with data. And then as a research studio, we also regularly contribute to a growing community of researchers and scholars within the AEC field through the publishing of scientific peer-reviewed papers mostly in scientific conferences and journals. So what you see here is a set of the papers that we have recently published in journals and conferences, and most of these deal with specific aspects of generative design. Okay, so the first project that I wanted to talk to you about is at the scale of the industrial product. And it deals with a project that we initiated in collaboration with airplane manufacturer Airbus. And very briefly, generative as a methodology is an outcome-based kind of workflow that combines the best of human creativity with the best of machine intelligence to achieve outcomes that may have not been possible to discover or achieve without one or the other. So we tested this technology with Airbus and partner up with them to achieve this goal that they have set back a few years ago, which was to reduce cost and CO2 emissions for their A320 fleet of airplanes. But instead of working right away on the full airplane, we started small. We started with a small wall, this partition highlighted in red, that divides the cabin attendants area from the passenger seats. And despite its simplistic look, it's actually a pretty complex component to design, and this is due to the constraints and requirements that come with it. It can only be 2 inches thick. It can only be attached to the fuselage through 3 points. It has to resist very high impacts, and then has to hold this fold down seat for the cabin attendants to use during landing and takeoff, which creates a very, very asymmetrical loading condition throughout the partition. So to solve this problem, we developed a custom geometric algorithm that is inspired by growth systems in nature, and that is also able to create a very large and diverse design space of options. And each option is a different type of lattice structure. You can see many of these go very much beyond typical engineering rule of thumbs and intuition. And then we use the power computation and generative design to use this algorithm to generate, evaluate, and evolve literally tens of thousands of solutions. And all of these are gradually optimized for goals. In this case, the goals were reducing weight and increasing the stiffness in the context of specific types of loading conditions that are specific to aeronautics certifications. The process was a very high-performing partition, and here you can see displayed with all the different components that make the partition. And one thing to note is that from the beginning, this was meant to be designed for industrial production. So the model took into consideration a lot of precision engineering. Finally, we tested and 3D printed and made the full physical prototype that was fully 3D printed in metal. And as you can see here, and some interesting results were that this partition is 50% lighter than current partitions currently used in the A320 fleet of airplanes, as well as 10% stronger than the current partitions currently used. And right now it's undergoing several types of certifications and a few modifications in order to join soon the A320 Airbus fleet. Shifting scale, the second project that I wanted to talk to you about deals with the scale of architecture, and more specifically with the scale of office spaces. And here the project is the new office for Autodesk in Toronto, Canada. The project involved the design of 3 floors within an existing building in Toronto for around 300 people. And I'm going to use this project to explain a little bit more in detail the different steps that we go through to implement generative design for architecture. The first comment about generative design for architecture, unlike its applications within the engineering domain, is that it becomes part of a larger ecosystem of tools and methods. For example, we can integrate more qualitative assessments of the solutions through virtual reality, but also once the option is selected and eventually built, Internet of Things or other types of sensors, we're able to collect information about how the space is used and its performance over time, and use the same data to feed it back into the same generative design model, which in turn becomes a sort of living model that can be used for post-occupancy modification purposes. So it's a model that continuously learns about how space is used and adapt the space as necessary over time. So again, this is a video that summarizes all the different steps that we go through. Another observation about generative design when applied to architecture is that it becomes a much more complex problem and application. And this is due to the innovation and the computation of social and experiential features that are very typical of architectural design, but also hard to quantify. So for this project, we included 6 different goals, and 2 of them, as shown here, were directly derived from human survey data that we collected from the occupants of the space, and were computed as the human factor of the whole workflow. And then the generative design process follows these 3 canonical steps: generate, evaluate, and evolve. In the generate step, we create a geometric system that is able to create a very wide and diverse space of design possibilities. And here you can see how we're splitting the floor plate into different neighborhoods that can have different shapes and sizes. And then within each neighborhood, we can automatically place amenity bars like meeting rooms and then allocate all the necessary desks. And here you can see how we can create several types of configurations of the layout by changing a few inputs. In the evaluate step, we design and develop automatically measurable goals. The first one is AC that minimizes the travel distance between each team and individual to their preferred amenity or other teams. Work style preference that measures the suitability of each neighborhood to the team's preferred lighting and acoustic levels. Buzz that maximize the amount and spread of high activity zones throughout the space. Productivity, which is a goal that measures the visual, that tries to minimize the visual and auditory distraction sources from each desk location. Daylight is a pretty normative analysis that is meant to maximize the amount of natural daylight that penetrates the floor plate. And then finally, views to outside, which maximizes the number of unobstructed views from each desk location to the outside. Then once the first 2 steps are completed, we're able to run the optimization and evolve the designs and improve their performance generation after generation. This plot is showing the gradual improvement of the solutions over generations. And then we can use data visualization techniques to plot all the different designs. Here, each dot corresponds to one solution, and see how it relates and performs along different goals. Then we use this technique to identify a subset of high-performing solutions that is used to discuss together with all the stakeholders the trade-offs, the conflicts between metrics, and identify one solution to move forward with. Finally, the result is that we ended up selecting was a space that was very rich in feature, where each neighborhood had its own unique character. And also each neighborhood and the space satisfied the requirements and preferences of each individual, but also enabled different types of work modalities. And then one thing that I'd like to note also about this is that we went beyond the one-size-fits-all kind of approach that is very typical to workspace design. And here are a few shots of the completed and utilized space. One thing that I also want to note here is that it was very important for us to build this space as a full-scale physical generative design test that we're still using to date and learning from it. The third project is at the scale of low-rise residential complexes, and this was done in partnership with construction and development giant Daiwa House, which is a company based in Japan. And we collaborated closely with their rental housing department, which focuses on rental housing business proposals to landowners. So what we did was embedding generative design with their business and within their workflows. In this case, we incorporated several constraints from local building code to ensure that every solution that we would create was code compliant. One interesting thing about this project was also that we leveraged historical data from Daiwa House in the form of a unit catalog. And what the generative design model would do was assembling in 2D all these units on the site, but also assembling the units in 3D through unit-to-unit assembly requirements and unit-to-unit construction requirements. Eventually, the output can translate it as a BIM model into any BIM reader platform, in this case, Revit. The model, similarly to the previous examples, accommodates different types of variables to create different kinds of solutions, different types of constraints, as well as we incorporated different types of goals, which in this case are primarily focused around financial performance. Here you can see the model in action, and this is a kind of test that we generally do when developing new generative design models, where we do a continuous exploration of the input space to make sure that the output is what we'd expect. And this again is a video to show the optimization in action, where we create different solutions, thousands of options, and automatically score each option along all the different goals that we are optimizing the solutions for. Another test that we do when developing generative design models is looking for trends over time and testing the model against a very simple problem. In this case, we wanted to make sure we wanted to look for trends of the location of the massing and shadow casting. And you can see how the model was eventually able to learn how to place the building within the southern east area of this given site in order to maximize the number of units that could be placed on the site. For one case study, we ran a full optimization, and here again, we're plotting the solutions in a similar manner as we did in the previous projects. And what interesting insight was that we, contrary to the intuition of the company, we were able to find highest return of investment in scenarios of low density unit aggregation. So in this case, in the 6-unit family of options versus the 12 units that are the biggest ones within the site. Eventually, also this tool was extended to be applicable on any given site within the Japan area. And currently, Daiwa House is further extending this tool and for their own purposes. The last application is at the scale, more at the scale of the city or urban design. And this project was done in collaboration with Van Wijnen, which is another construction and development company, but in this case based in the Netherlands. They're very highly specialized in prefabrication. And for this partnership, we developed a generative design model for the design of a net zero energy and affordable residential neighborhood in the north of the Netherlands. So for this project, I have just one video showing a summary of the application of generative design. The workflow follows, again, the 3 steps, highlighting again the problem agnostic feature of this workflow, and that can be applied to any scale. We identified one site that Van Wijnen was working on, collected all the constraints from local building code, as well as requirements from the developer, in this case, several types of modular units and prefabricated apartment units, and then included 7 different goals, which is a mix of environmental related goals, financial type of goals, and more urban design related goals like views, variety, and backyard size. we run our optimization and evolving and optimizing the solutions along these metrics, and then identify a subset of high-performing solutions. And together with the client, we identify the most promising one that can be further developed and move forward within the following design phases. And also in this case, the tool was further extended to make it reusable for the client, and themselves as well, very much like the Daiwa House project, are currently working with the tool and testing it on their own. All right, thank you very much.
Thank you very much, Lorenzo. All right. So open it up now for Q&A. Sorry, Molly, was there a word that we were supposed to list now, or was that afterwards?
We'll go ahead and do that at the end.
At the end. Okay. Stay tuned for the last word. Okay, so some questions. Thank you again to all of our panelists, Carlo and Lorenzo. So specifically for Lorenzo first, can you tell us a little bit more about the software that you use? Do you have any out-of-the-box programs, or do you code and develop the programs specific to each project?
Yeah, that's a great question. Being part of Autodesk Research, we are kind of separate from the product side. So we tend to develop custom solutions to, explore what is new out there and what can be done that is different than what is available today. So generally, what we do comes out of, new stuff that we do in-house. However, just recently, Autodesk has launched generative design in Revit. So many of these functionalities are actually already available to users who have Revit. And the optimization framework is called Refinery. And it's leveraging also a visual programming platform called Dynamo, also accessible from Revit.
Excellent, thank you. Next question to Carlo. With my experience with the COVID tracker, that was very influential for me to really see the data displayed visually and get some complex interaction between multiple data sets. The importance of this, especially as we look at the issues such as equity, diversity, and inclusion in our current political landscape. Can you speak a little bit more about some of the potentials you see here, or some of the challenges, and how you could utilize similar tools?
Yeah, that's a good question. So I think in general, what I was trying to get across, and hopefully I did that successfully, was that, tools like the COVID-19 compiler and just data analytics in general can help us understand the nuances between, in the case of COVID-19, the nuances between how the virus is spreading and the various how that differs across different communities and different neighborhoods, and the various factors that contribute to, the spread of the virus. And I think the same thing in general, data, understanding data in cities, understanding data in the built environment can help architects and other built environment professionals take a more nuanced approach in their decision-making to do with things like programming and city development in general. And so, I think the opportunities are vast. I think, I'm all for increasing the amount of data available to practitioners while at the same time respecting privacy. And I think, there's opportunities for, in future pandemics, if the data is available at a more granular level and a more granular timescale, I think it helps people like myself and other analysts get more targeted in how they address some of these challenges. I hope that answered your question.
It did, thank you. So kind of related to that, the data sets. So have you found the data sets or identifying reliability of data sets, or those folks who have voices to actually give input on those data sets challenging, or can you speak a little bit about that?
Yeah, sure. That's definitely a big challenge for us at Topos. And I think in general, the data sets we use, so I'll talk specifically about COVID and then talk about how biases and challenges in data affect some of the other work we do around cities. So for COVID-19 specifically, at the beginning, there was definitely challenges in terms of figuring out which data sets were reliable, which were updated at a frequency that were good for us. And which ones were at a granular level. And, I think we landed on New York Times for the number of cases across the country. And then as time went on, different municipalities like New York City and others kind of released more granular data at the zip code level. And so I think we're at a fairly good place now. We're getting data from the Census Bureau. We're getting data from, as I said, different publications like New York Times and the CDC. And we there's a lot of data sets we hadn't worked with before. So we got data to do with existing conditions across communities in the US, which we hadn't worked with before. Things like hospital beds, number of hospital beds also. But I think in general, there's a challenge with people that work in the kind of data to get reliable, unbiased data. So, this is very appropriate conversation right now because this is a census year. And so I hope everyone listening has filled out the census, but things like the census have been in the past inherently biased, right? Like I think New York's response rate at the moment is around 45%. And the census is super important. It informs the work we do, but it also informs the distribution of resources that the cities and urban planners rely on. And so the responses in census are, people that respond tend to be of higher income and higher educated. And so other people that are not counted, lower communities, marginalized communities, for whatever reason, tend to just not fill out the census in the same amount of numbers. And so this definitely biases some of the analysis we do, some of the way that resources are distributed in cities. And so these are challenges that I think everyone should be thinking about and trying to address in their work.
Thank you. And then similarly, Lorenzo, you mentioned both interviews with the participants of the spaces that you're designing for and utilization of Internet of Things technology to generate some of the data sets. Can you talk a little bit about that?
Yeah, I think one very big opportunity for these kind of methodologies is to shift the focus of the architect from just designing the building and delivering the building drawings to have a more holistic view on the life cycle of buildings. So with this kind of research, we're trying to really add a layer of intelligence throughout the lifespan of buildings. And right now we're doing a lot of work in order to create more compatibility with ongoing data collection and the improvement of the intelligence of the model in order to make changes to the spaces. And the survey that we've at the beginning of the design of the office space for Autodesk is just one kind of data collection that can be done over time in order to improve the performance of the space. So right now we don't have any specific example to show, but it is on our radar and we're really pushing forward within that kind of domain.
So what, also for Lorenzo, architects have often expressed concern about generative design or feel that it's threatening technology to their services. It strikes me that the process that you worked through for the clients identifying their metrics of success and then going through the various iterations to quantify solutions and making them an active participant um, is a great way to illustrate how it could be utilized by architects in the process in a way that's less threatening. Um, have you found that process of involvement to be super successful?
Yeah, I think the component, it is a great comment. The human component is always there within the generative design process. As a matter of fact, it's just an additional tool that architects can have in their arsenal of tools. And instead of just automating or replacing some task that the architect currently does, it's really just augmenting the possibilities that architects can create, really options and solutions that may have not been possible without the tool. The architect is always the main driver of the process, from the setting of the initial inputs to the curation and selection of the outputs. But also there is a lot of creativity and a lot of ingenuity required in the crafting of the design space. So like one reason why the talk was called Design Space itself is really this focus on the quality of the designs that are inputted in the system. I always like to mention that regardless of how intelligent of an optimization framework you may have, or if you're using other types of machine intelligence algorithm, if you input into the system bad quality design spaces, you will always just get bad quality design outputs. So really the craft space, it's a design problem, and it is a problem that architects can really contribute to.
Thank you. And then I guess for each of you, in order, what you both started in architecture and still are in the architectural industry. What got you interested in the particular paths that you've taken and keeps you going and energized?
Sorry, Nate, I think I missed the final part. You were breaking off a little bit.
Oh, I'm sorry. So what got you interested in the particular line that you are following right now, and what about that keeps you energized and going every morning?
Carlo, then you want to go first, or?
Sure, I can go first. What got me interested? So, I mean, I'll try to, it's a long storied thing. I mean, I think from my very early days of architecture school in undergrad, I was always kind of interested in this question of authorship. And I don't want to get too theoretical here, but I was always interested in the question of authorship. And I remember coming across the work of Peter Eisenman early on in his kind of research and approach to trying to think about, it was a very rudimentary form of algorithmic design and trying to remove the role of the architect or the author from a project to, remove the kind of signature from a design. And so, stemming from an interest in automation and authorship, I kind of were always interested in the question of, okay, what evidence-based approaches, what data-driven approaches can we use to construct a design or a space? And so, yeah, what started as interest from that, I got deeper into the world of data science and data-driven approaches. And so, that led me to my time at WeWork, and then which led me to my time at Topos. So, yeah, I'm still interested in those questions.
Yeah, I guess I have a similar story to Carlo, which, by the way, we were classmates in grad school, and we're deskmates basically for the entire time of our presence in grad school. So we kind of developed this interest together towards a more data-driven approach to design and architecture. In addition to that, I'd like to mention, in relation to your question about what keeps us going, I think there are tangible problems that we're trying to address, including climate change and including the, the housing crisis that is emerging, and we can see year after year, in order to accommodate the housing demand in the next like 30 years, if I'm not getting my numbers wrong, we will need to build thousands and thousands of buildings every day. I think it's something like 13,000 buildings a day. So there's a big responsibility, I think, that is given on the architects in order to make sure that all these buildings meet, certain levels of comfort for the people, but are also less impactful for the environment. So methodologies like these really give an additional and very to the architect to really make sure to meet those demands and deliver buildings that are less environmentally intensive with negative impacts, while still delivering unique solutions that really reflect the aesthetics and unique design sensibility of each designer. So I think, yeah, there are really tangible, there's a tangible urgency, I think, for the use and the shift, the mentality of the architects community to a more outcome-based approach.
Excellent. Thank you both very much. So we are at the conclusion of our program. So thank you all participants for joining us today, and special thank you to Carlo and Lorenzo. The third and final word to enter into the CE questionnaire is ledger. See that in the chat box as well. There will be a link in the chat box to that CE form that you can fill out. So thank you again for participating, and have a wonderful day.
Thanks, everyone.
Thank you.